चैनल को सब्सक्राइब करो पहले, हाँ जल्दी करो, मुझे पता है कि आप लोग नहीं करते हो, वीडियो देखते हो लेकिन सब्सक्राइब नहीं करते।
So this video we're going to look at running a t-test. Now you can see there are a few steps to a t-test, and the first one is that there is an assumption that the variance of each group you're comparing is about the same. Now the variance is very similar to standard deviation, okay, so it's about how varied the data is. So the variance or the variation of data here, is it similar to the variation of data here? It doesn't mean the values are the same, it means that they're spread out in a similar way. Okay, so in order to do that, we're going to use something called an f-test, and I've given the example here with A and D, and I'm going to go ahead and work through example B since that one's not shown. So we need the data analysis tool pack, which I showed you how to add in with exercise 2. So data analysis, and we're going to look for the f-test, which is here. F, test to sample for variances. Are they about the same or not? Click OK. My first variable range, that's going to be here, and my second variable range is going to be here. I don't have labels this time, and alpha, that's just if I'm looking at 95%, my alpha should be 5%, so I'm going to leave it at 0.05. My output range, make sure to click back into this cell, and I'm just going to output it here below and click OK. So variable 1 was low, I'm going to relabel that, and variable 2 was high. And we can see the variances here, not too far apart actually, 0.07 and 0.16, so those aren't too different. And if we have a look down here at the test, this is our p-value, and our p-value is greater than 0.05, which means that we have to assume that the null hypothesis is true, and that means that there's not a significant difference between the variances. So that's here. So there's not a significant difference, so we're going to assume that the variances are approximately equal. Okay, so because we're going to assume the variances are approximately equal, we're going to do a t-test assuming equal variances, just like shown here in this picture. So if we go back to data analysis and look for equal variances and click OK. Now my variable range 1, I'm going to highlight the same data I did before. Variable 2. Okay, now when you're doing a t-test, your null hypothesis is that there is no difference. So your two means are the same, and if the two means are the same, the difference between them is 0, right? So if you subtract them, you should get 0. So that's what we're always testing against, that the means are the same. So we're going to put a 0 in there. I don't have labels, and I'm going to continue with alpha is 5%. My output range, make sure again to click back in that box, is there, and click OK. So there's my t-test. Now I'm going to just do a two-tailed test, so that's assuming I'm just testing is there a significant difference between the two means, which would be the mean for the low and the mean for the high. So is the flight time significantly different for the low condition compared to the high condition? So I'm going to look at the two-tailed value, which is here. So my p-value, I'm going to compare it to 0.05. That value is less 0.046, which means if I come over here, right, so if p is less than 0.05, there is a significant difference between my means, so we cannot assume that they are equal. So let's put the results into context. If the results are different, so if my means are significantly different, it means that the flight time was significantly different for the low and the high. Let me just label these. Okay, we can see here that for the high condition, the flight was 2.37 seconds approximately, and for the low condition the average flight time was 2 seconds. So we can say that the flight time under the high condition was significantly greater than under the low condition because our result came out to be statistically significant. Okay, so have a go with parameter C and see how you get on.